Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna.
Hey, Dianna. In our last episode, and I think even in our conversation before we got online, is that you ran into a question about testing. And it was like, and looking for a resource for that. And
yes.
Can you explain the context of that question a little bit more?
Well, it's a matter of there's a dichotomy with testing, right? You either don't test it enough, or you test the wrong things, or you over test and you want to test everything because you're unsure about it all.
Mm-hmm.
And the question had to do with this particular person is working with a group that wanted to test everything all the time. Mm-hmm. And testing can be expensive. But then on the other hand, how can you back off, or what can you do to encourage the team to back off a little bit without swinging to the other side of the pendulum swing, which is where you're not testing enough. So they're two different problems, but related.
Mm-hmm. Okay. Yeah, and I know that I recommended the book that Carl and I published a couple of years ago on the process of reliability engineering. And we thought about doing the process of quality engineering, process of this engineering process, because it's essentially the same. Is start with what are you trying to achieve? What information do you need, which is commonly done by testing and too many times. And then why do you need it? You know, if you're going to run a test and nobody cares about the results or even going to look at it, you've wasted a whole lot of time and energy doing something that has no value or less than no value because you're not working on stuff that had value. This is related to our last episode on capturing values.
Yeah.
What's this? If I'm going to spend $100,000 running this test, I better get information worth $1 million. Otherwise, why are we doing this?
And I think that's the important question is why? And I'm not talking about 5 whys. Mm-hmm. I know a lot of quality people love that. Yeah. But really, instead of what are we testing, how are we testing it, just to revisit why, or challenge yourself or your teammates. Why are we testing this?
Yeah. Well, I usually ask, who needs the results of this test and for what purpose? And if the purpose is only worth $10 and we're going to spend $100,000 doing it, this sounds pretty silly. We shouldn't be doing this test. Whereas this is the go, no go, do we cancel this project or we continue? Well, then the test is pivotal, the information it provides for the future of this product.
And you wouldn't necessarily see it. And you're right, this does relate to our previous episode about value. Because once you distill it down into, instead of why, you said you use who needs it and what for. Mm-hmm. If you distill it down into that with the value, like you said, it's worth $10 to us versus a project cancellation. It becomes obvious. But when you're in the middle of designing your test plans and you're looking at all the questions that you're responsible for answering and making sure that the product's performance is sufficient, those kind of questions can get lost. And you just don't think about them anymore because you're so in the weeds of how are we going to perform this test and when are we going to do it?
Right.
Yeah.
Yeah. There's Chris Jackson uses the term, focus on the vital few. Even he uses a electric door lock kind of system as a feature, or not a feature. I'm trying to think of the teaching term for it, but as a way to talk about process improvement and testing and all kinds of other things. Now, you and I and any of our listeners could look at a drawing of, say, this smart lock type system and think of like 47,000 ways to test it. And we could test every component, we could test every system and subassembly, we could test this, we could test that. We could look at different environmental conditions and on and on and on. How many times does it get open and closed? What's the strength of slamming it? What kind of damage does that do? It's not hard to think of ways to say, oh, I need better information for this. All right.
Yeah.
If you get that information, are you going to do anything with it? Are you going to change the design? Is it going to matter at all? And all too often was we wait till the last round of prototypes and then we put them in test and then we're already shipping the units before we get results. And I stop and ask the teams, like, if we get results that say this product is really bad or really good, are you going to change anything now that we're shipping? And they'll look at me, no, we'll wait till next year and rev the product then.
Yeah, the only decision at that point is, do we have a recall or not?
Yeah.
Right.
And we can do that with way fewer examples. And the first month of shipping would probably give us more information than anything we do in the lab. But every test has a purpose, or it does it work for some period of time? Does it work under these stresses? Does it work as expected? You know, when we put it under an oscilloscope or probing for voltages, does it answer a question we need to have an answer for? And if every question requires a test to get there, we'll never leave the lab. We'll be testing every product we ever make. And that's just not good business.
No.
So it's start with the decisions. If you're in charge of the setting up the test regime for a product, what decisions are important? Go talk to the program manager, go talk to the senior engineers, go talk to the team and say, what information do you not have right now that you really do need before this project finishes?
That's another key too. What don't you have right now?
Right.
Because you might have data from a similar product that would kind of give you an inkling of how this one's going to perform.
Yeah.
So yeah, that's another key question.
Well, a good number of what I think good designers often just use intuition and their gut feels like, oh, I'm going to make it this big, or I'm going to design it this way, or I'm going to use this vendor, and they didn't run a design of experiments to figure out how to shape this flange. They didn't need to, and it wasn't critical. They over designed it enough they didn't have to worry about it. And if it was critical for mass or for this or that, the other thing, yeah, you could do a design of experiments. But very, very few people do that for the everyday decisions they're making on every design they're involved with. So testing is a supplement to that decision making when it's worth doing the test, is my opinion. But if you don't know what decision is trying to be answered, you can run off and do the perfectly wrong test and come back and say, here's the test results. He goes, well, I can't use that data. I needed it in millimeters, and you only tested to the meter. Come on. You should have known that.
Yeah. And so the designers are making decisions, and they know, like you said, they over design some aspects, or they're not concerned about some of the other details that maybe doesn't need to be tested. But then another source of information for that is your good old hazard analysis or FMEA.
Yep.
Those activities will highlight what's critical or what's unknown.
And that's the purpose of those tools is to prioritize what do we need to do because we either have unknowns or we need to address something that's not right. But it's a prioritization process. And I think that applies to the world of just testing in general for product development.
Yeah, there was, I remember a project where the designers were working with a outside manufacturer, so a contract manufacturer for an injection molded part. And the molder decided to develop the manufacturing process and started doing PQs on it, process qualification on it. And then the designer said, whoops, this other thing is now also important for our product. So they went back and revised the graphic and, highlighted something else that was critical to quality or
Mhm.
important. And the manufacturer's like, whoa, wait a minute. We've already got like the mold is done and we've got our molding process based on these other things. And this isn't, this completely changes a lot of things.
Yeah.
So being able to identify those things early in your design helps with not only the test engineers, but also the manufacturers too.
Oh, yeah.
Yeah, that
Yeah.
can
Yeah,
be a
definitely.
problem.
But it's the design process is full of decisions. And some decisions we just do and move on. It's from experience. It's similar to the last product. It's close enough. It's my experience with similar products. It's the advice of the supplier. Because if we analyzed every single decision, no product would get to market. It's just not possible. And so you have to prioritize. And
Yeah.
I found that the best way to do that is what are those key decisions? What are the big dollar decisions that really do need better information in order to improve the odds of making the right decision? Is this good to go or do we need to change it? Is this vendor giving us a solution or should we compare two vendors? And but the tests say hypothesis test of the performance of two different vendors in our design, their products in our design, is a test in search of information to inform the selection of that vendor. It's very straightforward. And everything we do in the lab, every test we do, doesn't have to have a whole, you know, details all out. Yet if it's cost more than $10 in 20 minutes, then you had better think it through because now that cost of the test starts to add up. So if you're going to take 20 samples and destroy them in some series of environmental testing, who needs that information? And are you going to give it to them in time where they can do anything about it? So if you find out it leaks when it's
Yeah.
misting out and nobody cares whether it's watertight or not because it's an indoor product in a clean room, well, don't run that test.
Yeah. So that sort of gets back to relating it to the requirements of the project
Mm-hmm.
and then which relates to the customers. And it's all tied together.
It is.
Which was why it can seem overwhelming because now you have your customers and your requirements and what's important to the project and the time to market and the timing of all of this. So it isn't easy, but it's not, you know, undoable. You can't just throw your hands up and say
Well, we'll just
whatever.
do, yeah, whatever. We'll do no
If
testing or all
or
testing. But
yeah, or we'll do all the testing. So I guess maybe that's part of what the problem is that there's uh, just not enough energy spent on really answering the why or the
yep.
who and the what for. So we just default to all or nothing. Whereas it is a lot of work, but it's necessary work.
Well, yeah, it is. I think of it this way is if you only have $100 to run your testing for this program, you really should budget that, to allocate that funding to the ones that make the biggest difference.
Right.
It's just obvious to me that if we have limited time and limited budget always when it comes to testing. And just because you can doesn't mean you should spend the money doing it. That money could go to other purposes that are higher value. Again, to reference back to our last episode, that has a better return for that investment. It's the same with your 401k plan or your retirement funds or anything you do in investing is if you give me $1 and I can't give you $2 at the end of the day, well, you probably could have used that dollar to have lunch instead and enjoyed it.
Lunch where, Fred? In
That's
what
true.
decade?
Yeah, well, I'm showing my age now, aren't
You could
I?
maybe get an ice cube to suck on.
Yeah. but not a container or napkin or anything
No,
like
they
that.
do give it to you in your hand.
That's right. Yeah, no, I did get breakfast in the Army in the late 70s for 73 cents. And it was all you could eat, but that was also in the late 70s.
Well,
So
I remember
showing my
gas was
age.
like 85 cents a gallon.
Yeah.
Yeah.
Yeah, that's another episode, but not for this
You
podcast.
know.
But the idea is that it's a combination of do what adds value. And to do that, it has to be connected to a decision that is, we need to have this information so that, and it's worth having that information because it's a $10 million decision. All right. Well, that means we can spend some money to get really good information, be, say even $1 million, because it's worth a $10 million decision if we get the decision right. And adding information to it assists with that. The testing is not just done just for testing. It's done with a purpose, and we can never lose sight of that. So prioritizing it, stacking them up with what adds the most value, where's the best use of this funding and tools and equipment we got, and sometimes not using them is your best choice. It's just because you have an environmental chamber doesn't mean you have to use it every time. That's a fallacy I see too many test labs get into. It's like, well, what
Yeah.
did you learn by putting it in there? Well, the chamber works. Like, okay, that's not useful to.
It was fun to break things.
Yeah, well, that always is true. But if you didn't need to know, you already have a good Pareto of what's failing in the field. You don't need to go to the halt chamber to find new ones. You got a stack there that have priority. So go work on those. But anyway,
Yeah.
there's, yes, it takes, like you said, Diana, it takes a little bit of thinking, which is something that we are paid to do, and then prioritizing, and then make good choices about what information you're creating. And sometimes testing is the right way to do it. Sometimes simulation, sometimes an engineering estimate is good enough. So testing's not the only option. And when it's done, it should be of great value.
Yeah, that's the other thing is testing isn't always the only option. And you can sort of work backwards. Like if you think you need a big test, but you're having a hard time, or it's you identified a test and you decided, you know what, our why isn't strong enough for whoever wants it and what for. So what other things can you do? It's just not that you need to just drop it.
That's right.
Is there an analysis that you could do, or could you uh, consult with somebody, an expert in the field, to just give you some more information for whatever you need, if you need
Yeah.
it?
Finite element analysis is a wonderful tool. It can
Yeah,
do all kinds of stuff and thermal mapping, and just, use a very simple test. Put your get your product running and use an infrared camera to take a picture of it. And why is that hot? Let's fix that.
yeah,
Versus putting it in, running it and running it until something melts or fails. No, we can spot problems in non-destructive ways very quickly in a lot of cases.
I wonder if some people feel like the test itself is, I don't know, they feel like it's more robust because it captures all, like if you're testing the product that was made in normal manufacturing, it captures all the variables. And
Well,
I
that's
don't
true.
know, sometimes there's a sense where the test itself is, um I don't know, I'm having a hard time thinking of the word.
Well, that's probably a whole nother episode. Is how do you what specifically do you experiment on? Is it the material? Is it the just the coating structure? Is it the chemistry? Is it the unit that it's on in attached to a system? Is it, do you need to test an entire car to tell if the paint is adhering correctly? Do you need an entire vehicle to test the paint? Is kind of the way I look at it. And no, you don't.
Right. Yeah, so component testing is another option,
Yeah.
component versus system.
Or if you
Mhm.
know that you've got great process control and the we're only testing to see if it's out of spec. Well, we're only testing 3 units. And we make a million of these things and we keep track of the dimensions. And here's our process capability. Is that defect rate not good enough for you? You know, kinds of things. Yeah, there's many, many options that if you sit back and think, how can I get that information? But that goes right back to where I started is you need to know what information is necessary. It's currently missing. And testing is just one of your options. There's many other ways to get information from all kinds of sources. And explore that before you commit to spending samples and time and energy doing a test. That's my 2 cents worth. And mostly
Mm.
it's probably another whole episode is there are test labs that have to keep themselves busy. Otherwise they say, well, we don't need you anymore. And so they'll always recommend using the test of the equipment that we have or this one that we don't have yet, but you should buy it. I've run into that before too.
Yeah. Yeah. I just went to a manufacturing show
Mm-hmm.
and I was talking to president of a company. He had been stamping metal parts since he was 14 years old.
Mm-hmm.
And he's president of the company. I would say he was maybe in his 60s. So
Mm-hmm.
he's been in the industry for a long time. And he said, they don't need to keep adding stuff to all the equipment. In order, it just gets in the way of making good parts.
That's right.
And it makes it more expensive. So the manufacturers had an edge. Oh, buy this new machine because it's got all the new doodads on it.
Right.
He just didn't think it was worth it. So sometimes, going back to basics, instead of testing on all that expensive equipment, maybe you don't need to do that. Maybe you need a simpler analysis.
Yeah.
Yeah.
No, I could go on and on. I'm going to make notes for more episodes because there's so much rich stuff in this thing. But if you're listening to this, what did we not touch on? What are the ideas of what garners we have to do this not do this? Or why do you go to the test lab versus doing something else? What's your take on this? We'd love to have you join the conversation. You can do that over at accendoreliability.com/go/SOR. Couple of ways for you to get in touch with us. Dianna and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways for you to join the conversation, and we'd really love you to do that. So I'm going to go test my refrigerator to see if we're recording this Monday after Thanksgiving weekend. So I still have leftovers. So I'm going to go see if they're any good. That's my next test of the day.
Well, you're not having problems with your refrigerator, right?
No, not at all.
Okay. That's just a good reason to go check it out.
That's right. Yeah.
Yeah. Okay.
Mostly because I have to open it to get the leftover turkey out. And I think I have some soup I made last night. So see
nice.
if that'll work.
All right. Well, enjoy your leftovers and I hope your refrigerator is okay.
Yeah, same. Thanks, Dianna. I'll talk to you later.
Okay. Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.